Okay, so I'm going to show to you how to tackle these questions. So apparatus shows a cell that can be used to determine the avogadro constant. Avogadro constant is used to find the number of electron in particular molecule or in a species. So here we have a variable resistor, and then we have power supply, and then we have a silver electrolytes electrodes, and then we have electrolyte Y. So what's the X actually? So X basically we can actually add ammeter, all right? So ammeter. Why we need ammeter? Because electricity pass through the silver chloride. So we have two silver chlorides. Silver electrodes. So one of this silver electrode um, acting as actually cathode, and the other one is actually anode. Okay, so because here we can see this direction, all right, and then we have resistor here, and then we have a X there, and then we believe that one of these is actually to determine the number of electron that pass through the circuit. So X is actually meter, all right. And next is actually a suitable electrode Y. So what's the electrode Y is actually, it is up to you, all right, as long as you have a silver ion in it. Okay, so you can write AgF or AgNO3 and then so forth. Okay, next is actually in experiment we have a I or current is 0.2 pass through 40 minutes, and then mass of silver cathode increased by 0.5 grams, and the charge of electron is minus 1.10 to power minus 19 coulomb. So how to calculate the number of moles of silver? So mole equal to mass divided by, okay, so mass of silver is actually 0.5 divided by AR, which is 107.9. So it is actually, if I use my calculator, then I can get 4.6 times to power minus 3, okay, mole. Okay, so and then number of coulomb is actually Q is actually I times T. Okay, so I is actually 0.2 times T is actually 40 minutes time, but then this one should be in second, so I multiply by 60, then I will have 480 coulomb. All right, now how many number of electron pass? So it means that each time we have this configuration, then we'll have a charge divided by uh, charge of electron. Okay, minus 1.6 times to power minus 19. All right, 19. Then I will have a 3 times 10 to power 21. All right, so okay, so basically I can calculate the number of electron needed to deposit 1 mole. So it means that if it is in 1 mole, then I have to divide this per mole of silver at the cathode. So okay, so I can just write here. Okay, so here I have a number of electron passes actually 3 times 10 to power 21. So it is actually for 1 mole, but for 4.6 times 10 to power minus 3 mole, then it is actually 3 times 10 to power 21 divided by 4.6 times to power minus 3. Then I will have 6.5 times to power 23. Okay, so this actually number of electrons needed to deposit 1 mole of silver at the cathode. Thank you for watching and enjoy.